I was called in to assess this technology by a company called Argus Limited out of Switzerland. They were a large contractor in Europe, and they also put in and did the maintenance of a lot of windmills over there. Peter Schiadelli, the CEO, called me up, introduced himself, and said, "Richard, we heard about you. You're a technologist. What we wanted you to do is come and assess the windmill technology." I said, "Hey, I don't know anything about windmills." This was 6 years ago. I said, other than they're not good looking. Number two, they're never running. When the wind's blowing, they're all stopped. I used to go drive through Palm Springs over here in California, and I said, they don't run. And I said, I think you guys have the wrong design. So he paid me enough money. I went over to Palm Springs, spent a few days out in the field with the engineers and that fixing these things. I went to St. George, Utah, and went there to where they repaired these blades. Took a look at what they were made out of. So when I took a look at it and I saw the very archaic way, the very old way that they're making these things by hand. Then I went over to Oklahoma, to Burgess, Oklahoma, to a windmill company. And I went to a couple other windmill companies in the United States and saw how they made them. I realized positively they have the wrong design, and positively they have the wrong material. So I flew over to Lucerne, Switzerland, went to a conference, sat there and listened to all of these engineers, professors, and so forth talking about the windmill industry. On the seventh day, I was asked to come to the podium to speak before the people of what I had found wrong. And I told them, in summary, I said, you guys have the wrong design of the blade and you have the wrong materials of the blade. All of them, of course, booed me because there's a lot of engineers there. And they booed me, and I said, when they got finished, I said, listen, you guys, answer one question. What's the efficiency of your design? Tell me, from 1 to 100, give me a percentage. What's the efficiency? Nobody answers.
Richard's focus when he invented this system was to create a device that would be low in maintenance. Because in the United States, everybody's tired. The utility companies are tired of fixing these big systems. Too much big cranes, too much downtime. And so economically it affects the performance of the units. So we wanted to get back to something that's smaller. We're not very big, okay? Standard 65 feet tall. 2 men in 2 hours can fix any component on the system. We eliminated the transmission. We do not feather props. There's no feathering of the props. Right. The mechanical steerage is gone because it steers like a parachute. When the parachute receives wind, it will automatically just reposition itself around a standard. So we don't have mechanical servo mechanisms here. We don't feather props. All that's eliminated. We don't have a transmission in there. When General Electric hangs these big ones, they hang 55 tons in the air for the total apparatus. By creating a device that allows us to capture energy from 5 miles an hour all the way up to 90 miles an hour in wind speed, elongates the ability to create energy over a 24-hour period. So your kilowatt hour output is much higher in a device that is not so sensitive to wind speeds. And so normal generators make energy from about 12 miles an hour to 28 miles an hour. Then they start to shut them down. And when the wind's blowing the best, they cut them off. Because the airfoil designs cannot handle that much wind. This device, when it loads up energy, okay, at 5 miles an hour, maybe only a few of these coils are working. When it gets to 20 miles an hour, there might be 30 or 40 coils working. When it gets to 30, 40 miles an hour, 300, 400 coils.
Okay, we're taking it straight up to 20 miles an hour. And you notice there's no noise. The key to what we're doing, this is the wind tunnel, causes about 10 decibel points. And this is out running by itself. When you turn it off and you at max speed, you will hear no noise. Large megawatt and a half is 112